So you're ready to get rid of your remote controls? Let's get you set up quickly. The installation consists of two parts. The first part is the Alexa skill setup, so that Alexa can understand our remote control commands. And the second part is the remote control web service setup. And this web service is responsible for actually executing our remote control commands. So let's start with the Alexa skill setup. We have two prerequisites. Number one is the setup of the Ask CLI. This is Alexa's command line interface, and it's a very powerful tool. You can use Amazon's web UI if you prefer, but as you will see down below during the installation, it's a very powerful tool, very efficient to create new skills. We also need to install NPM. NPM is the Node.js package manager, and since our skill is written in Node.js and has a dependency on the Alexa SDK, we need to use NPM to download that dependency. We start the installation by simply cloning the GitHub project. Simply pick a folder and do the clone. You can see that we have two folders here. There's the Alexa folder, which contains the skill code. And then there's the OpenHAB folder, which we will use later for the remote control web service. Let's drill into our skill implementation. And this is implemented as a Lambda function and as a custom skill, not a smart home skill. Index.js is the skill implementation, and it has a dependency on the Alexa SDK. So let's satisfy that dependency. There are two config files, and the project comes with a sample file for each. So let's create our own version of that sample file. Number one is config.js.sample. So we'll just copy that into config.js, which we will then modify later on. And we need to do the same for the voice model file. So we'll copy and create our own version there as well. And that is it. We are ready to create our skill. And all we need to do is use the Ask CLI with the deploy command. Give this a couple minutes, since this will actually create our Lambda function as well as our Alexa skill. And once your deployment completed, we can give your skill a test run. Of course, our skill doesn't execute any remote control commands yet because we haven't implemented the web service. But at this point, we can test the voice interaction. You can use any of your Alexa devices for that, or you can use the web UI with the test functionality as I'm doing here. So let's give it a try. Alexa, remote control.
Okay, ready.
Right.
Okay,
Switch to Apple TV.
okay,
Done.
okay, done.
All right, our skill worked. And for good measure, let's also take a quick look at our skill log files. As I mentioned before, the skill is implemented as a Lambda function. And this Lambda function was created when we issued the Ask deploy step earlier. So head on over to the Lambda console in AWS and select the Ask custom remote control default function. That's the one that was created for us. And find your last log entries in the log file. So start by looking for the start session entry. And this is logged when the user kicks off the session by saying Alexa remote control. And then the next interesting log entry is the send command. And send command is sent by the skill each time it is ready to invoke a remote control command. The first one that we see here is sent to the entertainment bedroom TV, and it's the mute command. This is actually sent automatically by the skill at the beginning of the session because we don't want the volume of the TV to interfere with future commands. So that's why we simply mute the TV until the session is over. Now look for the next send command. And this is sent to the DVR, and it's the write command. This was in direct response to our write command that we issued in our test. After that, we will see the input HDMI2 command, and this is how the switch to Apple TV is implemented by executing an input change on the bedroom TV. And then finally, as the last command, we will see another mute command. This toggles the mute state at the end of the session so that the sound comes back on. So our skill is working well, but it's only working with the predefined buttons and devices that come with the project. Now let's take a look how we can customize our configuration files so that you can add your own buttons and your own devices to your system. We will start by customizing the voice model. So go ahead and open the voice model file in your editor. The voice model defines the interactions with Alexa, and you will find this at the top of the file. We do not need to change that, but look for the list of remote buttons. This list defines all the buttons that are accepted by Alexa, and each button is identified with a global unique ID. And this ID is independent of the manufacturer of a remote control, independent of a device, independent of the web service implementation. This is a global name within your skill that we can refer to. And a button has a name. The name is how the user can refer to the button. And we also allow multiple names. So for example, if you look at the OK button, we also allow the user to say enter or select for that button simply by specifying synonyms. As you can see, this project comes with a long list of predefined buttons, but if you have any buttons that you would like to add to your system, all it takes is just add an entry to this list here, give your button a unique ID, give your button names for how the user can refer to your new button. Now, similarly, look for the list of TV sources. This list defines all the devices that are known in the system. And again, each device has a unique ID, and it has a set of names for how the user can refer to the device in your system. In this example, the user can refer to the entertainment bedroom TV as TV or as television. So again, if you want to add devices, simply add records here to this list. And the second part that we want to configure is for skill and more detailed devices configuration. And for that, open up the config.js file in your editor. The first object that we want to configure is the skill object, and it has a set of properties. The first one is the service host. The service host is where we send our web service command requests to. So we will talk about that later during the web service installation. And similarly, we have a service port for the web service. Next up, set the TV property to the ID of your main television. So the ID is what we just defined in the voice model. So for example, in the sample file, it is the entertainment bedroom TV. And we send the mute commands that we saw at the beginning of a session, at the end of a session. Those are sent to this device, as well as any input changes. So if you're switching from one device to another, like switch to Apple TV, those commands are being sent to this TV. Next up, you will need to define the TV mute and TV unmute command. The specific string for this command will depend on your web service implementation. And also note that often the TV mute and unmute command are identical because they simply toggle the mute state. And finally, specify the default device. Again, this unique ID is coming from the voice model here. And all commands at the beginning of a session are sent by default to this device. So in our previous example, our write command was our first command. And because entertainment bedroom DVR is set as the default, that write command was sent to the DVR. The next object that you want to customize is the device object. The device object contains an entry for each device. And again, these are the unique IDs that we previously specified for the device. And within each device, we have a buttons map. This button map maps the global button ID, for example, channel down, to a device-specific button command. So we're saying when the bedroom DVR receives a channel down button command, we want to send this string to our web service. Now you can see that these are almost all here one-to-one mappings from the button name to the actual command send. However, it depends on the implementation, and there are some exceptions, and that's why we need this mapping. So for example, the sample file here is based on Harmony Hub, and Harmony Hub for an Apple TV expects that when the OK button is pressed, that we send the select command, not an OK command. So this map here allows you to customize these commands as needed. This map also allows you to overall specify which commands are supported at all. So in our example here, the Apple TV will only support these commands. And if the user tries to invoke a different button on that device, Alexa will respond that that button command is not supported. In addition to the buttons map, you will want to provide the input attribute. And this input attribute specifies the command that we need to send to the TV to switch to the specific device. So input HDMI 2 is what we use to switch to Apple TV in this sample. And finally, you need to provide a name for your device. And this is simply a user-friendly name that Alexa uses in error messages to refer to the device. So overall, make sure that each of your devices are specified in the voice model with an ID and the names, and then provide the details for each device within the config.js. One quick note on configuration. Editing these configuration files is definitely gnarly. Making a small mistake, just missing a comma, can have very unexpected results and is difficult to troubleshoot. So in a professional skill, we would definitely expect to have some form of tooling support here. But if you find yourself in a situation where you're not sure if your format is correct, take a look at the troubleshooting section, and there are a couple of tools that can help with validating your configuration files. So if you've updated your config files, don't forget to issue another ask deploy so that your skill is updated accordingly. And that's it. You're done with your skill setup. So our skill is working well now, but we are not executing any remote control commands yet. And that is because we don't have a remote control web service running. So let's work on that next. To execute a remote button command, our skill invokes a REST API. And a REST API call is simply an HTTP call. And we're sending this call to service host, service port, where those two properties are defined in our skill object, followed by the URL REST items, and then specifying the unique ID of the device we want to send the command to. The body of the HTTP call is simply the command that we want to send to the device. So in our sample, if we want to send the OK button to the Apple TV, this would be sent to item entertainment bedroom Apple TV. And the command would be sent as select because we had mapped in our button map the OK button to the select command. Now it's entirely up to you how you want to implement the REST API. If you have an existing service that you can easily adjust to answer the skill's requests, then you're all set at this point. And if you don't have a service, then you might want to use the one that is provided here as a sample implementation. This service implementation is based on OpenHAB and Harmony Hub. OpenHAB is an open source home automation system, and Harmony Hub is a device that makes it very easy to send infrared commands to devices. So as prerequisites, you will need to install OpenHAB and you need to install your Harmony Hub. OpenHAB uses the notion of things and items, where things represent physical devices and items represent ways to interact with those devices. So let's copy the provided sample things and items files so that we can customize our own versions. So let's go to the OpenHAB folder, copying the items file and the things file. Let's start by editing the things file. In this file, we are configuring our Harmony Hub as a device within OpenHAB, and we're giving it the name main. And all you need to configure is the IP for your Harmony Hub. This is the IP on your local network. Make sure you give it a static IP, because otherwise, if that IP changes during runtime, then OpenHAB will get out of sync. In addition, you will need to provide one line per device that your Harmony Hub controls. You provide a name that OpenHAB now refers to that device. So this is a unique name that you can make up here. And you need to map this to the name that you gave your device within Harmony Hub. So this is effectively mapping an OpenHAB name to the Harmony Hub name. And that's all we need to do in the things file. Now let's update the items file. In this file, you need to provide one line per device. And you specify the unique device ID that we introduced earlier in the skill. And you map this to the OpenHAB device name that we just defined in the things file. So what we're expressing here is that any command that is sent to the entertainment bedroom TV will be executed by the Harmony Hub of the name main, and it will be forwarded to device bedroom TV and executed as a button press. And that's it for the items file. Now that you've updated your configuration files, simply copy them over to OpenHAB and then start your OpenHAB server. Take a look at the installation doc for the links provided there, because the specific steps for copying files and starting the server depends on how you installed your OpenHAB server. At this point, make sure that you update your host and port configuration that we updated earlier in the skill object. Remember the service host and service port. These are now the attributes you want to point to your OpenHAB server. So specify the IP of your OpenHAB server, and 8080 is where OpenHAB typically runs on. Now remember that the skill is implemented as a Lambda function executing on the AWS servers, and it has to call into our web service. And for that to work, the IP of the web service has to be publicly visible. Now that in turn has security implications. So please make sure that you review this link here to make sure you pick a mechanism that works well for your system. OpenHAB has a very nice feature that it automatically hosts a web service for every item defined in the items file. So simply by us defining our items file, we get all the web services that we were looking for free. Now let's test our remote control command execution. We don't need the Alexa skill for this. All we need to do is invoke the REST API by making an HTTP post request. And the curl utility can help us with that. Here I'm using Cygwin to invoke curl, and I'm sending a write command to the Apple TV. And there we go. The cursor moved to the right. So our web service through OpenHAB is working. So if you go back to your Alexa skill now, the skill can reach your web service, and you should be able to entirely control your devices through voice commands. Oh yeah, and don't forget to throw away your remote controls. Enjoy!